All right, here's a couple kind of basic verifies that I want to talk about again. Again, we don't have a lot of trig identities we know yet, again, other than the fundamental cosine squared plus sine squared equals 1. Otherwise, that's about it. So this first one, how do I look at this? Well, there's no fractions to add. And again, you can only focus on one side, so I'm definitely focusing over here. But I do see something interesting. I know cosine squared plus sine squared equals 1, and notice this is a cube. I don't know anything about cubing, so I probably don't want a cube in my problem. And then the second thing is this reminds me of a binomial where I can factor out the greatest common factor. Again, remember with binomials, like typically you have 2x squared plus say 8x, you factor out the GCF, which is the greatest common factor, which in that case is 2x, and you have your leftovers. So with binomials, that tends to be how you factor them. Remember, the only exception would be something like x squared minus 9, where it's a perfect square minus perfect square. That's when you factor into x minus 3, x plus 3. But so for the most part, when you get binomials, you tend to think of, okay, the fact that you're probably going to take out a GCF, greatest common factor. So when I see this, I'm like, oh, well, then I'm going to go ahead and factor out a GCF. And that just kind of comes from my algebra background. Right, and so then the next step, again, you don't want to jump here. You don't want to go straight to tangent of x because then I have no idea if you know what's going on. So you have to leave a trail. So cosine squared plus sine squared is 1. So you want to write that so that I know you get it. And then this last step, you can see sine over cosine, which is the definition of tangent of x. So that's good enough for me. Okay, so make sure I'm not having you write the reason off to the side, but I want to see enough knowledge that I know, oh yeah, they know that's 1. All right, and then you're good to go. All right, let's look at the next one. Both sides are kind of ugly here, but yet I mean, I could do 1 minus cosine squared and do sine squared, but then how does that help me with this? So trying to get this to go back to this seems more of a pain than trying to mess with this and try to figure out here. So again, I'm going to start with this side because I tend to think it's the uglier side. All right, so what is there to do? So that's your hint. Well, there's a squared there. So again, you're going to want to multiply that out. Now, this again means 1 plus cosine or cotangent alpha times 1 plus cotangent of alpha. Sorry about that. Don't tell me that's a binomial. The only time you get a binomial is x plus 3, x minus 3. Then you get x squared minus 9. But otherwise, if you multiply this guy out, you're going to get a trinomial. So first, outside, inside, last. Otherwise, some people memorize that it's this squared plus you double that, and then you square the last thing. Okay. If you don't have that memorized, then you're going to have to FOIL it. So first, outside, inside, last. So minus 2 cotangent alpha. All right, so at this point, I'm like, oh, awesome. See how those guys are opposites and those cancel. All right, so then I get 1 plus cotangent squared of alpha. All right, and when I see that, I kind of realize that, oh yeah, that's some variation of that fundamental trig identity because it has a cosine square or has a squared in it, even if it's cotangent squared, and it has a 1 in it. So I'm thinking, okay, that's something that I know. So I need cotangent squared. So sine squared of alpha would give me that. So I'm going to divide everything by sine squared of alpha so I can figure this trig identity out. So these guys would give me a 1. Here, again, that's the definition of cotangent squared. And this guy would be what? Cosecant squared of alpha. All right, so at this point, I get cosecant squared of alpha. And we're like, okay, but I still need to get this. Well, how can I get stuff in the denominator with this? Well, probably putting it in the definition. Remember, with trig identities, we very rarely have cosecant and secant and cotangent in there. We tend to get rid of them. So I'm going to go ahead and rewrite this with what it really is. Right? And then I look at this and then I'm like, oh, I need to get it into cosine. Well, right now it's in sine. Well, that's not that hard of a fix because, again, I know anytime I see squareds, I'm always in the back of my mind thinking of the fundamental trig identity. So let's see, sine squared would be what? 1 minus cosine squared, which makes total sense when you look at the other side. You're like, oh, now I get what's going on. So instead of leaving my answer like this, I need to get it in this form. Well, that's just factoring, right? This is kind of what I reminded you at the beginning of class, or at the beginning of this podcast, is x squared minus 9 is x minus 3x plus 3, because you have a perfect square minus a perfect square. So I'm just going to factor that guy. There we go. And that's my final answer.